Very welcome again to assessment of the fetal status using the cardiotachograph, and you have now progressed up to lesson 6, and we're going to do part 2 today, where we will do the accelerations, the different kinds of decelerations, and the different abnormalities regarding the contractions. Now, firstly, accelerations, and as we have said many times now, that accelerations are actually good signs and they are usually good predictors of fetal well-being. It tells us that there's enough oxygen going to the fetal brain that allows the fetal heart rate to accelerate when the fetus moves, etc. So we're always happy when we see accelerations. We have said that often during labor, the accelerations for some or other reason disappear, and it's not clear why, although it's not abnormal. Now, when we look at the different decelerations, we have said there are the different types of decelerations: early decelerations, late decelerations, variable decelerations, and prolonged deceleration. So first of all, we're going to talk about early decelerations. Early decelerations is, the definition says, it's a mirror image of the contractions. It starts the moment that the contraction starts. It reaches the peak when the contraction reaches its peak, and it returns back to the baseline at the end of the contraction. And the main reason for this is usually head compression. When the fetal head goes down into the pelvis, there's a lot of parasympathetic nervous endings around the fetal head. And when there's a lot of pressure now as the head goes down into the birth canal on this parasympathetic nerves, it stimulates the baroreceptors. We remember we've said baroreceptors stimulates parasympathetic nervous system. Parasympathetic nervous system decreases the fetal heart rate. So the moment that the contraction comes, there's pressure on the fetal head, it stimulates the parasympathetic nervous system, it decreases the fetal heart, we get this deceleration exactly the same time when there is pressure on the fetal head. The moment that the pressure on the fetal head is released, the fetal heart goes back to normal again. And this usually is late in labor. Very late, transitional phase of labor, and often in the second stage of labor, and it's highly unlikely that it will be in early labor. So if you do get and see decelerations in early labor that looks like early decelerations, it might not be early deceleration. So be careful, because we usually say that if the baseline is good, and that's why it's been highlighted here, that if the baseline is good and there's good variability, early decelerations are not abnormal. It's quite normal. There's no hypoxia, etc., as long as the baseline and the variability is normal. But if, as I've said, it happens in early labor, it's highly unlikely that it might be early deceleration. And here's a typical example of an early deceleration. Here you can see that the moment that the contraction starts, the deceleration starts. We can see here that the peak of the contraction and the peak of the deceleration are almost over the same time. And then we can also see the end of the deceleration and the end of the contraction more or less the same. Here, a small contraction, small deceleration. Here again, the contraction and the deceleration almost mirror images of each other, and here more or less the same. Now, our second type of decelerations are late decelerations. And what happens here is, I almost want you to remind you of the uteroplacental exchange that we have done in lesson 4 in the physiological changes or physiological control of the fetal heart. And I hope that you can still visualize that picture of the villi that's been surrounded by maternal blood. And we have said that during a contraction, the spiral arteries are being constricted, they are being occluded, there's no new oxygen-rich blood that go into the intervallar space. Now, and we have said normally the fetus has enough reserves and they can survive. But we've also said that if this goes on for a very long period, or there's prolonged labor, or there's very long contractions, or too many contractions, the frequency of the contractions are too many, we might eventually get that fetal hypoxemia develops. And it develops in this villi. It goes with the umbilical vein, or the blood that goes now from the villi to through the umbilical vein to the fetus. There's now a lack of oxygen in them, and when they get to those chemoreceptors that sit there at the top of the fetal heart, it stimulates these chemoreceptors, which stimulates the parasympathetic system. And we've said when the parasympathetic system's been stimulated for the 100th time, we get a drop in the fetal heart rate. Now, the moment that the contraction ceases, the uterus relaxes, and there's now our spiral arteries open again, there's now new blood going, new oxygenated blood that goes to this villi and sinuses and intervallar space. It removes this stimulus of the chemoreceptor, because the blood that goes now through the chemoreceptors are normal, and there's no reason for stimulating the blood anymore, and the fetal heart returns to normal. Now, you can see why it's a late deceleration, because the contraction first need to start. When the contraction starts, there's a constriction of the spiral arteries. Then this whole thing happens where there's a drop in the maternal oxygen, cause fetal hypoxemia. All these needs to get to the chemoreceptors, and then we get the deceleration. So the deceleration is after the contraction has started. And then as soon as the contraction is over, all these messages need to go again to the chemoreceptors and recover this whole deceleration. So the fetal heart only returns to normal after the contraction have been gone already. Now, some very important aspects about late decelerations. First of all, like we've said, we get that the decline of the fetal heart rate happens with or after the contraction order, or the peak of the contraction. And the greater the time between the peak of the contraction and the deceleration, the more or the greater the hypoxic insult. It just shows you that the fetal heart rate just takes much longer to recover, and that tells us that there's a big hypoxic insult. And also, where there are late decelerations are being caused by hypoxia, as we've said now. There's not enough oxygen in the intervallar spaces. So this same pattern happens with each and every contraction. So the late decelerations will appear with each and every contraction. So we say it's repetitive, and we say it will definitely happen with more than 50% of all contractions. In most cases, it happens actually with 100% of all contractions. Now, when these late decelerations are associated with tachycardia or a decrease or absence of variability, which are also bad signs of hypoxia, we say this can be an omnia sign. Now, when we looked at the definition of late deceleration or decelerations in general, we've said that a deceleration is when there's a decrease in the fetal heart rate of more than 15 beats per minute. Now, even smaller amplitudes of less than 15 beats per minute, in the case of 10 or even 5 beats per minute, but where they recurrently happen, it's very important. So it might be an early sign of late decelerations, so we should very, very, very carefully monitor them all. Here you can see a typical example of late decelerations. Now, we don't see it being printed here on the middle of the um, CTG graph here, but this graph has gone at a speed of 3 centimeters per minute, which is very important for us to know when we come to interpreting this CTG. Here we can see is the peak of the contraction, and the peak of the deceleration falls after the peak of the contraction. Same story here, is the peak of the contraction, peak of the deceleration falls after the peak of the contraction, and same story here and same here. If we look at the duration of the deceleration, we see that it's almost 1 centimeter, 2 centimeter, 3 centimeter, a little bit longer than 3 centimeter. So it's almost 1 centimeter, 1 minute long that this deceleration lasts. Here we see 120 beats per minute. There's 150 beats per minute, and there's 180 beats per minute. So the baseline of this fetal heart rate is just above 180 beats per minute, and you can see that the fetal heart rate decelerates here to up to about 120 beats per minute. So from 180 to 120 is about 60 beats per minute that the fetal heart rate decelerates. But what's very important also in this pattern is that you can see there's very little variability present here as well. Now, there are 3 very important aspects here that's abnormal. The one is the late decelerations, the one is the lack of variability, and the other one is the tachycardia. And we've said if all 3 of those signs are present, it's omnious. Now, if we look at our third type of deceleration, that's variable decelerations, and the name tells you exactly what it is. They vary, and they are usually associated with occlusion of the umbilical artery. Remember also in lesson 4, where we discussed the different, the baroreceptors and the chemoreceptors, we've said I used the example of a hose pipe that we kink. Now, this is exactly the same. This is variable decelerations are usually due to occlusion of the umbilical artery because of the umbilicus might be too tight around the fetal neck, or it's been kinked in some other way. And that causes an increase in blood pressure in the fetal circulation. Because remember, I've said if you open the tap and you might let water out in the pipe, there's a certain pressure in the pipe. But the moment that you kink the pipe, the pressure increases in the pipe, and exactly the same here. It increases the systematic blood pressure, and that stimulates the baroreceptors, which, remember, stimulate the parasympathetic nervous system. Parasympathetic nervous system slow down the heart rate, and we get variable decelerations. And the moment that this pressure is decreased in the sense that there's a little bit of relief of pressure on the umbilical cord, we get that the baroreceptors are not stimulated anymore, and the fetal heart rate goes back to normal. And these variable decelerations are usually quite short decelerations. They seldomly last, or they're not really supposed to last longer than 60 seconds. And we will come back to the 60-second story just now. Now, variability or variable decelerations account for the majority of all decelerations in established labor. They are responsible for more than 90% of all decelerations during labor. And they usually V-shaped. The previous decelerations that we've seen, the early decelerations and the late decelerations, were usually more U-shaped. They were more kind of not so sharp and deep, and more in a U form, because they also take a little bit longer to recover. While here we usually get a sharp deceleration, and it recovers very quickly. Like I've said several times, it varies. It varies in size. Some are small, some are bigger, some are deep, some are more shallow. It differs in shape, and it differs in timing with the contraction. Some of them, sometimes it falls with the contraction, sometimes before contraction, sometimes after a contraction. So there's absolutely no pattern between the different decelerations. They vary all the time. As I've said, it's usually an abrupt decline in the fetal heart rate, and it usually recovers then very quickly. And it varies with the successive contractions, doesn't look the same. And the definition of a deceleration is the same here as well. It's usually longer than 15 beats per minute, and it lasts for longer than 15 seconds. Now, other aspects about the variable decelerations that's very important is, now we've said that it counts for about 90% of all decelerations during labor, and some of them are normal and some of them are not normal. What is typical about normal variable decelerations? When is it normal and when is it not normal? We have what we call a 60-60 rule. It's normal or uncomplicated when it usually drops less than 60 beats per minute, when it's less than 60 seconds in duration, and we have the presence of shoulders, which is a short little acceleration at the beginning and at the end of each deceleration, and I will show it to you on the example just now. These decelerations are repetitive and intermittent. Sometimes they keep on with each and every contraction. Sometimes they're intermittent with contractions, and they usually have a rapid onset and a recovery. They are these typical short, sharp type of decelerations. As we've said, they vary in their relationship with the contraction. Sometimes they come with contractions and sometimes they come on their own between contractions, but they most commonly come with contractions. They're not, and remember we've also said that in lesson 4, that in most cases they're not associated with hypoxia. They are associated with changes in pressure, in the blood pressure of the fetus because of this occlusion of the umbilical cord. And because of that, there's the trigger for the deceleration is a barrow pressure difference and has nothing to do with hypoxia. Later on, we will see when we get to the more abnormal variable decelerations, hypoxia start to play a role as well. As we can see here, when the cord compression is recurrent or prolonged, and we get less and less. Initially, the trigger is pressure differences, but then as the occlusion in the umbilical cord stays and becomes more serious, we eventually get hypoxia, and then we get also stimulation of the chemoreceptors, and we get the typical signs of hypoxia. Now here you see an example of a variable deceleration. You can see they all vary. You can see they don't look like it's the same, like, but for example, the late decelerations all look more or less the same. Here you can see this one is much deeper than this one, for example. This one is much longer than that one, and this one, for example. Some of them are with contractions, some of them are between contractions. So there's absolutely no pattern in them. And here you can see the typical accelerations, small little accelerations in the beginning and the end of the variable decelerations, which is a sign of, as we've said, what we call shoulders. Now here you can see this variable deceleration is just shorter than 60 beats per minute. It decelerates here from around 140 beats per minute to 100 beats per minute, so it's 40, it decelerates with about 40 beats per minute, and the same here, it goes down to 100 from about here 150, so it's about 50 beats per minute. So if we look at all these decelerations, they are shorter than 60 seconds and less than 60 beats per minute, so they're still within the normal side, if I can call it like that, of the 60-60 rule. Now, I have said very important aspects about the variable decelerations is to check the baseline and the variability. If the baseline and the variability is good, like in the previous slide that we've just seen with the example, the baseline was good and there was a lot of variability. It's usually a very good sign. Abnormal variable decelerations are those decelerations that's above where the fetal where it's accompanied by tachycardia, where the fetal heart rate goes now above 160 beats per minute, and we get or we get reduced variability. So we have an abnormal heart rate as well as an abnormal variability, or it drops more than 60 beats per minute, or it's longer than 60 beats, it lasts longer than 60 seconds. So here is our 60-60 rule, where it's worse than the normal 66, and or when there's delayed recovery back to the baseline. We know that these variable decelerations are not normal anymore. Then our fourth type of decelerations that we're talking here about is prolonged decelerations. That's a deceleration that exceeds 3 minutes. It lasts longer than 3 minutes. And the fetal heart rate stays usually for less than 80 beats per minute for longer than 3 minutes. And we usually have a reduced variability within the deceleration, and that is usually definitely associated with fetal hypoxia and acidosis. And this is usually a bad situation. It requires emergent intervention, and we will come to that in the next lesson when we talk about hypoxia. And they can, the reason for these prolonged decelerations, it's usually some or other acute episode that cause these prolonged decelerations. It might be a sudden drop in the maternal blood pressure, for example, in the case of an epidural, where we get a sudden drop in the maternal hypertension, blood pressure, it might cause these prolonged deceleration. It might also be a sudden head compression in a very quick second stage, and we get that. Remember, we've said there's a lot of parasympathetic nerves endings around the fetal head, so that might cause the parasympathetic nerve stimulation and a prolonged deceleration. Acute rupture of the placenta, which goes together with the maternal hypotension, because the moment that we get acute abruption, obviously we get a maternal hypotension and a drop in the blood pressure, and also a drop in the fetal heart. We also get that sometimes in the case of severe uterine hyperstimulation, where we get more than 5 to 6 contractions per 10 minutes, and then also the hypoxia gets so severe that the fetal heart drop and we get a long deceleration. And here's a typical example of this long deceleration. You see here was already a little bit of lack of a decrease in variability, and then we had a normal fetal heart rate that decelerates then to here below 90 beats per minute, and it stayed there. Now lastly, we look at the uterine activity and what's abnormal there. We've said in our lesson 3, right in the beginning, that the only thing that we can really accurately determine regarding the uterine contractions is the frequency of the contractions. How many contractions do we get in 10 minutes? We can, to a certain extent, determine whether the contractions are strong and how long they last, etc. But that's not accurate determinations. The only thing, as I've said, is how many contractions are there in 10 minutes. And we've said that if there are more than 5 contractions in 10 minutes, it is what we call tachycardia or hyperstimulation of the uterus. And this is often being caused by uterotonic drugs, drugs that cause contractions of the uterus. Oxytocin and prostaglandins. Now, what happens if you again remember the uteroplacental blood circulation, that picture of ours, and that the maternal arteries, the spiral arteries going to the placenta is being occluded during contractions. We see that in this case it's been occluded, and then the moment that the uterus relaxes, they go new oxygen to the intervillous space, but then immediately almost the uterus starts contracting again. So this period of recovery where new oxygenated blood can go to the intervillous space is then very short, and that eventually results in fetal hypoxemia. And the only way that one can treat that effectively, or the best way to treat it effectively, is to stop the uterotonic drug if we can. If it's oxytocin, it's usually easy to stop the IV infusion in which has been given. If it's prostaglandins, it's not always that easy to stop it, but if possible, one should do that as quickly as possible. And that brings us to the end of lesson 6, part 2, and it's quiz time again. And you're almost at the end. So I hope that you do well in this quiz so that you can carry on to lesson 7, which is the last lesson in the series.